Welcome to episode 9 of the SoothSight podcast and part 2 of my interview with Dr. Lloyd Colegrove, one of the godfathers of AI in the chemical manufacturing industry. In this video, we talk about how to get started in AI, how to handle interdisciplinary collaboration, the importance of having humans in the loop, economic considerations, and areas where AI is particularly useful and operations. Thank you for tuning in, and please don't forget to like and subscribe.
Companies that have all sorts of data at their disposal, but until they hire someone extremely knowledgeable like yourself, or maybe they work with us or somebody, how they have no ability to make sense of it.
Okay. So what I interpret this question as being, how do you get started? And the first thing I advise people is know what problems you want to solve. Because while every tool might do the same thing, they rarely do things in the same way. And the users may have a different approach in their mind about how they'd want to go through the debridement. And so having people that are focused on looking for the right tools and the right tools and marrying them to the right opportunity in their operation is best. So do you need to get more production out of your plant because it's sold out and every pound you make more means more money for the company? That is the classic best place to start. And there are many tools that could go do that. So you need to be out beating the bushes for the right vendor with the right solution for you and your people. I am not a big fan of programming it internally in my company. Now in Dow, we can do this. We can do anything. But if I'm a small company, the reason I don't want to leave it to a couple of people in my company to do this for me is, what if they leave? What if you can't afford them anymore? What if they get bored? Then you've lost a capability that you could be paying someone else good money for up-to-date programming and up-to-date approaches and up-to-date help, right? I got called into a plant we acquired one time because their artfully programmed complex Excel spreadsheet no longer ran the site. And I get there, I rush into this place. I have to get on a plane and fly halfway around the planet into this place. And we're in a room and they're showing me all the functionality of this Excel spreadsheet. It did stuff you did for us. It did stuff other companies did for us. It was amazing. And I said, so why doesn't your spreadsheet work anymore? And they said, well, the person that's working on it no longer is working on it. Oh, did they die? Did you fire them? Maybe they retired. No, he just got bored. Didn't want to work on it anymore. But they relied on this whole supply chain, but the process, oh Lord, that's a classic example of why you don't want to do it internally unless you've got a lot of people focused on making it work. So I spent a lot of time consulting with companies that want to get started, and the one thing I tell them is you've got to someone's got to be dedicated inside the company to champion things. They've got to be looking outside, and I give them recommendations depending on what they're looking for, who they should go talk to. But I never give them one. I want them to talk to several different companies. A lot of companies, by the way, and I'm saying this to all the potential customers out there, I arrived in a company that was into navel staring back in the 90s. They never went outside and looked at anything. And much of the ideas and the inspiration I got for the things I accomplished from about 2000 to when I retired, the year 2000 when I retired, was because I went out and talked to people. I went out and found out that either they had the same problem and didn't know what to do, and we'd mull it over generically, or they might have a solution that I could find that would work for me. And companies that don't send their employees out at least once or twice a year to get intelligence out in the universe, especially in data analytics, I don't understand that. So they do need to get out and look more at that. And then they do need to create a partnership with their IT organization. Typically in our industry, they are different from manufacturing, although they support manufacturing. Most IT organizations, by the way, don't know what manufacturing does with their digital thread. They just know they need to keep it running, and so they work on all the business deals with IBM or Microsoft or AT&T or you name it, da 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 da. But they don't know what we're doing with it. Most people in manufacturing, we know what we're doing with it, but we can't figure out why they're making such stupid decisions about who's our vendors. Well, it's not stupid decisions. They're doing the best they can, but there has to be a better symbiotic relationship between the people providing the digital thread and the systems that are managing all the different gaps in the order to cash versus the needs in the plant itself for manufacturing and using the data to its best end, right? Which is anticipating problems, solving problems, avoiding problems would be the big one for me, and being able to manage that with a workforce that is knowledgeable in what AI can accomplish. If I may, Chris, I don't think you need to train all your employees on statistics, data analytics, and AI. I used to think we did, but 20 years doing this taught me it's not reasonable, it's not possible, and it really doesn't help. What we did start doing was training the resources on when to call the right people for the right help, when to recognize an opportunity. Because the story I told you at the outset of this conversation, I recognized an opportunity for the data that honestly I had no right to recognize, because if you look at my Dow career at that time, I would not have run into what my idea was. I happened to be at a unique point because, as you told everybody, I have a PhD in chemical physics. I had a very, very broad graduate program, and I got exposed to all sorts of things. And it was that mindset that I took with me that 10 years later or 12 years later, all of a sudden made me realize, there's a better solution here. I don't know how to do it, but I know there's a better solution. And since not everybody can have that experience, it's incumbent upon the people in a company to figure out how they're going to start to shed light on the opportunities. One company is going to have me come speak to their workforce in particular on this subject, probably in the next couple of months, because their workforce needs to know that you don't need to know how to do this, but here's a way of identifying opportunities that needs this capability.
Let me, if you don't mind, pick up on this point too. How is this background that you have, obviously very impressive, but in chemistry and physics and spectroscopy, how has this influenced your approach to data science and analytics? And then to your point about symbiosis, I mean, how do you approach interdisciplinary collaboration between, in your case, chemists and engineers and data scientists? Any particular or successful collaborations that you can think of where you really had to merge these types of people?
Well, fundamental problem solving did that. We brought in top flight chemists and engineers, and each one of them knew when they had a role to play and when they didn't. Please understand that what I learned very early on at Dow with a degree in chemistry was that I would walk into a plant and talk to engineers, and they were very capable of talking about engineering, but I realized they didn't really understand the chemistry. Same thing, I could walk into the chemists and ask them what's going on in the plant, and they'd give me chemical reactions, but they couldn't talk to me about the engineering. Now, can I do both? No, absolutely not. But I recognize that's a gap because both of them have to come into play. And by the way, most chemical companies will either describe themselves as an engineering company with refugee chemists or a chemistry company with refugee engineers. And I guarantee you the engineers that are refugees in their company know it. And I guarantee you the refugee chemists in the engineering company also know it. I one time surprised an audience of young people at Dow in R&D. When we were talking about fundamental problem solving, I asked everybody in the room to raise their hand if they were working on a secret project, something that you couldn't talk about outside of their labs and their buildings. And everybody raised their hand. All had secret projects. And I said, who wants to bet me $10 that if you just told me what you were working on, I couldn't go out and find information about your project in the external literature in maybe a day or two. Everybody was shocked, absolutely shocked. The problem is they believed that the work they were doing in their labs was, really proprietary, and that they couldn't look outside into the data in the rest of the world to figure out how to make what they're trying to do get there faster. We've walked away from going into the literature and looking for the fundamentals. Okay, one of the biggest projects that we solved in Dow, and you've been asking about that, we were building a plant, and we were getting towards commissioning of this plant in a far-flung corner of the world, and we realized that one of the plants that was built to help clean up what this plant was creating wasn't up to the task. And our data engineers, our data chemometricians, AI people came back and said, guys, here's the process capability of the plant. Here's the process capability of that remediation step. We don't believe the remediation is going to work. Here's why. And we needed more data. And a buddy of mine and I spent an entire weekend going out into the world looking for this information. We needed kinetic information. We needed work on something I'm not going to tell you specifically what it was, but a highly researched technology. Okay. Well, the funny thing was we found a professor at a university who had done research in this area and had published externally information tangential to what we needed. We also had a bet that that person had the information we needed in a file cabinet somewhere. So we were going to contact this person, different country, different language, in a country where you typically wouldn't do this, by the way. It would have been very gutsy to go to this professor and ask them. We outfitted a scientist with a lot of money, cash, with registrations and everything. So we were doing this above board. And we got an entourage of people to greet them at the airport. And this, by the way, this professor was retired. So we needed to go find this professor's file cabinet in their apartment, in the city they lived in. Showed up at the door. Professor greeted us warmly. We explained through an interpreter what we were looking for. And this person smiled and went running off into a cabinet room, brought back this file. We filed through, found exactly what we wanted. We made copies of it. And we tried to hand this individual cash money, good money for this work, the value of this data. At first, they wouldn't take it. They were so pleased that somebody was paying attention to their information. But they took it finally. We explained that it had value, and my company was very ethical, and we were going to pay for that value. But the reality is that there is nothing out there that isn't described, at least tangentially, to whatever it is anybody's doing. It is super, super rare that anybody, even in Elon Musk's company, is doing something so super hyper secret that nobody else knows about it. I'm sorry. But our world, we think that it is, and we have lost the ability in the last 20 years to know that you've got to go into the fundamentals, go look for the information elsewhere. My graduate research hinged on one paper that was published in an arcane German scientific journal that nobody read. It was written in German. When you publish in a language other than English, mostly nobody reads it. And I spent months rooting through my library looking for things till I finally found it. And if I look back on my graduate work, everything hinged on that one stupid paper, which didn't give me the answer I needed, but it got me darn close. Right? So what happens today? I use the analogy. Chris, if you were a student of the 80s or 90s, you would walk into a library and there would be something you would see immediately opposite the checkout desk. Do you have any clue what that is?
Dewey Decimal System.
Right, card catalogs, especially at a school like I went to, massive card catalogs. What are students finding in that space today?
Probably a tablet.
No, actually, they don't use tablets anymore. There's a coffee house there. Why do they not use tablets and computers? Well, they got rid of those because now the students have them in their dorms. The only reason students go into libraries these days is to find a quiet place to sleep or study or have a group project worked on or go to the coffee house. And that's hurting our process industry a bit because students have lost the internal discipline and the knowledge that the things you need to know are actually out there. There are some search engines that are very good at helping you find it, but you've got to use those search engines, and you've got to be introduced to that when you're in college, because high school isn't going to do it for you. And Google is great, but it's not going to do scientific research for you, really. Although Google does have some things that will do that. My point being, though, is that we are changing our workforce. We are changing how we get data. We are changing everything, which leads me to this final point. When you come out of university today and you've done all your work from your laptop in your dorm room, or heaven forbid, because of the pandemic, we had to get the last 2 years of our engineering degree from home, what happens when you walk into a chemical company? For the most part, you're walking into the veneer of today with the computers and all the cool things companies are trying to do, but the heart of 1980. The things you really need to do your job, it's not obvious where you're going to go get that information. And we make it harder and harder for our workforces to get into our proprietary information because we don't want other people stealing it. There is information in my former company that some people will probably never get to see because of where their passport's from. But it would really help to run that plant a lot better. And this is just the reality of today. So what do you do about that? Well, companies have to take these measures to protect their intellectual property, but they need to change their behaviors around how they get the information that people need to know to the people who need to know it. And whether it's AI or it's real-time analytics, there is contextualization that comes with both of those things. And that contextualization is the information that we used to keep in our heads or put in a 3-ring binder in a library somewhere, but now needs to be available to operations or available to the researcher, maybe if it's an R&D project. And that information needs to come with the data. And oh, by the way, that's something we asked you to come help us with, I do believe. Long time ago, and it's still developing. It's a massive, slow work in progress.
So I saw a quote where you said, for those who say that chemical plants will be run by AI, I say not so fast. There is not a data set complete enough for an algorithm to run a plant without human monitoring and intervention. It is for the humans to learn to use AI to help them run the plants, not for the other way around, not the other way around. Do you still feel this way? And can you provide any examples of where humans are still necessary despite, these advancements in AI, machine learning, data science, and in chemical plant operations?
Well, yes, humans are required because the data sets do not contain all the information that will cause the plant to do things that you do not expect. What you're looking for is when you're running a chemical plant, you're always worried about unplanned events. They can be small or they can be big. What we've done in our data journey in my former company was start to get ahead of those things that were just on the periphery of our focus, because it was the things on the periphery of our focus that were getting out of control, and we were so focused on what we were trying to do that we missed those opportunities. All right, so you have a chemical plant that is running now, and you've got it running completely on AI. Who's going to understand the physics and the chemistry and the engineering behind that plant? Who's going to have day-to-day interaction with that plant to actually repair it when things are going wrong? What happens if you have a raw material that comes in with a impurity or something like that that'll foul your plant or otherwise make the product go wrong, and you don't even have the measures there to look at it? AI is not going to solve this for you. AI is not going to repair your plant for you. And there's an article that's coming out now, I think, in a science journal. This is something I should follow up with you later, Chris. It's talking about the fact that in our society over the last 30 or 40 years, we touted the role of specialists. Specialization. Everybody should become a specialist. This has actually been something that our general society has been on for about 100 years, according to the article. It started with Henry Ford and building cars in mass and giving people specific jobs to do in the assembly line. It's educating engineers to understand one particular thing really, really well. Okay. Well, the article is a shout out to generalists, and I'm a generalist, by the way. I can see when something could go wrong or something might be going wrong, even if I don't know anything about what that thing is. And the chemical operation requires specialists, people who understand very specific and deep technologies within a particular unit operation, and also people that can look across the bigger picture of all the different inputs into the plant. And AI is not going to do this work for you. AI will help you do your work better, but there's nothing you can do to make AI any smarter. It just isn't going to happen. And the whole artificial intelligence juggernaut, very, very powerful tool. A hammer is a very powerful tool. A hammer works great on nails. It really sucks when you're trying to unscrew a Phillips head bolt in a piece of wood, though. You can get it to work if you pull hard enough, I suppose, but you can also break it. In my mind, and by the way, as I talk to people and as I learn more about developing technologies, I would be very afraid if I lived near a major chemical plant where there was nobody running the plant, because I know that the AI system that's running it doesn't have all the information it needs. And if that company's not doing what it needs to do to allow people to understand the process, interact with the process, monitor the process, get involved in the nitty-gritty of troubleshooting the process. By the way, if you're not a mechanic and your car breaks down, what are you going to do?
Ask ChatGPT.
Well, yeah, your car is stranded on the side of the road. AI can tell you your car may be getting sick. AI is not going to fix your car. And if we got rid of all the mechanics, all the cars are going to eventually die on the side of the road. Sorry.
No, I totally agree with everything you're saying. And part of what I'm doing on a regular basis is educating people that it's an enabler, but not, it's not just a silver bullet, right? It's not magic. And it's an important message that you're espousing here. I'm wondering, do you, and I think I know the answer, but do you think there will ever be a time when plants can be, let's say, almost fully run by AI without human intervention?
It depends on the definition of almost, but I would say no.
Yeah,
so here's the deal. I think it was GE or DuPont, and I can't remember which company, back in the 90s, tried to build a plant that they termed quality by design. So the plant was going to be designed to make a certain product and controlled so well that they could dial in the polymer parameters they wanted as the raw material came in and get exactly what they wanted coming out. And it worked. And AI could probably control all those dials and things. They shut the plant down, I think, after 2.5 years. Why'd they shut it down? There's that old nasty capitalistic thing that you got to make money in what you're doing. Elon Musk can blow up a rocket over the Gulf, but he's not. At this point, he doesn't feel like he needs to make money. Okay, his purchase of Twitter proves that. Sorry, I probably shouldn't have said that in your podcast. But the idea is that you've got to make money. And I don't remember who built the plant, but they shut it down because they couldn't make money. Why couldn't they make money? Because the cost to put all that automation in that plant was so high, they couldn't charge their customers for that product. Why couldn't they? Well, there are other products on the market that were being done the old-fashioned way, with a lab, some process control, and a bunch of people working in the plant. So doing the analytical in a lab, in a batch series, having a couple of sensors in the plant operating it, is actually a very cost-effective model for doing what we're trying to do. And if you want a fully AI plant to run, You're probably not going to be able to take a 40-year-old asset and convert it to that, by the way. It's not designed for that. You'll have to build a brand new plant with all the bells and whistles, and a return of cost, your ROC, is be so freaking high that you're going to have to go out to your customer and say, I'm sorry, you got to pay us twice as much as our competitor for this product, because we did it with AI. Customer's going to go back to your competitor and buy it from them for half the price. Why wouldn't they? Because their process is run by human beings. Their process is managed that way. And they have to return money to their investors. So the people that I did get in an argument with a guy who told me that this is 3 years ago, that a guy told me that in 5 years, the first chemical plant will be run completely with AI. I called him out and I said, no, it won't. And he got mad at me, but he was a data scientist. He wasn't a chemical engineer and he wasn't a chemist. He didn't understand anything about the economic realities of the chemical industry, the practical engineering aspects of the chemical industry, the chemistry of the chemical industry, the liability the chemical industry holds, the commitment we have to our communities to try to keep everybody safe and not insult the environment. The company I worked for, we really took that to heart and tried our best not to do that. And so AI would help us, but we weren't going to rely on AI because, you know, what happens when something goes wrong? Are we going to blame the AI? I'm sure the public would love that. So the point is that you're not. I don't think as long as I'm alive, and hopefully I've got another 30 or 40 years to go, I don't think you're going to see it. And I do believe that the chemical industry is smart enough not to ever pledge to do something like that. They're mature enough not to ever pledge something like that. And the realities of what the chemical industry is in terms of its age, its infrastructure, and everything means it'd be really hard. By the way, I told you that in the 70s, my company designed their own process control systems. They've replaced most of it now in 2023, so that's 70, 89, that's 50 years, but they haven't replaced it all. Some plants are still being run on that old system because it's the economics of changing. Can you make profit for your shareholders while doing something like that? Does it make sense? And honestly, I think the death of old control systems in any large company will simply come through natural causes. We've decided there are other economic reasons to build a new plant or to replace a plant or to no longer sell that product. And so these old systems will slowly fade as we shut things down. But this idea that you're going to go in and change your data systems, your technologies, and all these things because a new something comes in that's better, it's got to pay for itself, and it better pay for itself quickly because our investors want their cut.
Yeah, it's like that old saying, if it's not broken, why fix it, right? So what are some, let's take it a different way then, what are some specific areas within plant operations, or maybe even more broadly, where AI has proven to be particularly useful?
Okay, it is particularly useful in understanding process variation and reining it in. It is particularly useful in explaining anomalous behavior, things that surprise you, and you want to know, well, why did this happen? I didn't see it in the data I was paying attention to. Let's go figure out if there's other signals, and it usually can show that. It also is quite handy in helping to model performance based on different stresses you might put into a plant. You can do fundamental modeling, by the way, for sure. Some of our most sophisticated engineering technology packages can do this, but it is also very handy in a multivariate sense to use AI to help us understand how plants would behave if we stress them. How do you stress them? Temperature, the mean temperature goes up, the mean temperature goes down. Global warming, how's that going to impact our production in a region? And by the way, global warming does not just mean it gets hot. It means it also can get really cold, right? how if you impart an impurity by accident in your process, what are the likely outcomes of that? Those kind of things. Soft sensors is a huge area of research within the chemical industry. That is an area where you're just asking your AI to monitor the process and look for anomalous signs without a bunch of people standing over a computer screen constantly trying to niggle with the data. It doesn't mean it's making any decisions for you, but it's certainly alerting you to things. The equivalent of that is the actual mechanical sensors, or the instruments we have attached to the sides of distillation columns or in plants, doing Raman, IR, separation science, monitoring the process as it goes. Soft sensors would be a cool way of not touching the chemistry, but still understanding what's happening to the chemistry. There are numerous review articles and books out now, because I encouraged my AI team to contribute to these things and write them, that they did from 2015. I think I've seen the latest publication is 2021, so they're pretty recent, talking about all the different applications that AI can provide to you. But I would still say that if a customer wants AI in their life, they should try to understand what problem they want to solve first, and then come talk to a provider for guidance on how their approaches are going to help them with that problem.